Hello guys, so this is a continuation lecture from the last one that we did on financial mathematics. So you can search the previous video just to check out what we did on the last video, which is part one of this series if you haven't watched it. So without wasting time, we'll tackle the first question. So let's read here. Let me just get my marker first, a pen to write. All right. So they're saying Tanda invests 120,000. He is quoted nominal interest rate of 7.2% per annum compounded monthly. All right. We already know what to do, right, when they say it's compounded monthly. So 6.3.1, the question says calculate the effective rate per annum correct to 3 decimal places. So they want us to calculate the effective rate per annum. So you'll notice something here. They mention nominal, they mention the nominal rate, and now they are mentioning the effective rate. So now they are asking us about the effective rate, but we are given the nominal rate. So, which means we need to understand the relationship between these two. There is a relationship between these two. So that's what we need to apply. We need to apply our knowledge of the relationship between the effective and the nominal rate in order to be able to find the effective rate. So the formula to get the effective rate would be given by, if I can say 6.3.1. So I guess most of us, if not all, know this formula. So you just take this one would represent the effective rate, and then you equate this to 1 plus what I normally write as I to the m divided by m to the power m. So this one here is the nominal rate, and the other one, this one, is the effective rate. So we already have the nominal rate is given, so all we have to do is to plug in. What is our nominal rate is 7.2%. That can be written as 0.072 divided by 12 because it's compounded monthly. And then we are going to raise this to the power of 12. I hope you guys are still following. And then now we can solve for I, which is our effective rate. This would be equal to, if you can type this in your calculator to find what this is, or you can just raise it to the power of 12 already. I just want to go straight forward just to not take long on this video. Look at me. Okay, 12. And then I'm just going to subtract the 1. We are taking this 1 to the right hand side. Then I'm going to punch in this whole thing into my calculator to find the answer. So that gives me, it gives me 0.07442. So this is equal to, if you multiply this by 100 to get the percentage, this would give you 7.442% per annum. This is per annum because it's an effective rate. So that's it. We are done with that part of the question. So we move on to the next question. So the next question says use the effective rate, which we just calculated, to calculate the value of Tanda's investment if he invested the money for 3 years. So we want to know what the value of the investment would be after 3 years. So just gonna go to the right of my screen. So we have 6.2, 6.3.2, right? So the formula, someone guessed it, it's going to be A equal to P, open bracket, 1 plus I raised to the power N, because we are using the compound formula. So this A would be that value that we want to find after 3 years, and then this P would be the initial amount that Tanda is investing. How much did they say he's investing? There, it's given 120,000 Rand. So this is going to be simple. So we have 120,000, open bracket, 1 plus the effective rate, which we just calculated, which is 0.07442. I'm just going to use it as it is. And then I'm going to raise this. I'm going to raise this to 3 because the term is 3 years. So that's it. You can put this in a calculator. What will it give us? If we put this in the calculator, we get 1.2403. There we go. A is equal to, multiply this together, we get 148,836.19. If you do not get this answer, just check what you used here. If you used a rounded value, or you used all the value from the calculator, including all the decimals. So that's it. We are done with this question. So we move on to the next question. Yeah, today I feel like I'm very fast. I hope I'm not losing anyone. So 6.3.3 now says, suppose Tanda invests his money for a total period of 4 years. So now if the period is 4 years, but after 18 months makes a withdrawal of 20,000, okay, how much will he receive at the end of 4 years? So basically, Tanda is investing the same amount of money here at the same effective rate, but for 4 years, and he's going to withdraw 20,000 after 18 months, which is 1.5 years. All right, we have all we need. So let's tackle the question. For 6.3.3, let's just use a timeline. I think a timeline will be great for this question, just so that we can see the picture of what is happening here. So I'll have T1, no, let's start T at T0, and then end at T4, which is the end of the 4th year. Then we'll have 1, 2, 3. Oh, need an eraser. What did I just do? Okay, this will be 1, 2, 3. So we have T1, T2, T3. So somewhere in between here, maybe let me just use a different color, yellow. Somewhere in between here, we have 18 months here. Yellow is a bad color. We can't see clearly. So somewhere here, it's the 18 months where this guy is going to withdraw 20,000. 20,000 here at 1.5 years, which is equivalent to 18 months. So let's go. So we still use the same formula. You are going to use this formula. A is equal to 1 plus I to the power n. But in this case, we need to consider the withdrawal. Someone else would want to take this step by step and do it separately. Like for the first part of the 18 months. But now, in this case, I'll just, okay, I left P here. I was surprised that I'm starting already by opening a bracket. Okay, so this will be 120, 120, and then just go to right for more space. This will be 120, 1 plus the effective rate, or let's just use the other rate, actually, the nominal rate. Let's just use the nominal rate just to show them that we are smart. So this, okay, for us to use the nominal rate, I'll need to change the formula that we are using here. We are going to use this one. Yeah. So this is going to be 12. Then we'll raise it to the power of 12 times 1.5 years. And then at the end of the 1.5 years, which is 18 months, we are withdrawing 20,000. Right? So this here will give us the value of the investment after 1.5 years, given that 20,000 has been withdrawn. And then this whole amount will then be invested for a further 2.5 years. So this will be 0.072 divided by 12 and to the power of 12 times 2.5. Dang, that's 2. That's a 2. So yeah, this is how we would get our answer. So I'm just gonna punch in the first part in the calculator the way it is, but you can just write this, like type this and write it down, and then solve this first part, then subtract the 20,000, and then type this in the calculator and then multiply. But yeah, you can also go my way or your way or your teacher's way. 113,642.54 no, 5947. This is it. So these are the decimals, yeah, these are the decimals. This represents this whole answer for this. And then I'm going to multiply this by this one, which is 1.1965. I'm just going to leave it here for the sake of not writing all the decimal places. And then A is going to be equal to 135,981.73. Again, I'm rounding this to 2 decimal places. your answer might be slightly different if you have gotten rid of some of the decimals on any previous step, like this step, for example, in this case. So there we go, guys. I hope you were following. And if you have any questions or would like us to tackle another question relating to financial mathematics, you can let me know in the comments. But from us, that's it for today. Thank you.